Hello everyone, and welcome to day one notes of our probability and statistics unit. Let's get started here. We are going to be talking about the fundamental counting principle, and this says that if a decision M can be made in M ways and decision N, whatever that is, can be made in N ways, then the two decisions can be made in M times N ways. We'll talk about that in more detail coming up. So, for example, an ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. And so I have, to figure out how many cones are possible, if you can choose 1 flavor and 1 topping, I'm going to take the number of cones I have times the number of flavors that I have times the number of toppings that I have. And I'm going to get a total of 360 different arrangements for how many possible cones you could make with those, under those parameters. Okay, now we talk about this idea of factorials. The notation here is N exclamation, and it is defined as the product, that would be a C, of all natural numbers from N, whatever you're starting with, down to 1. So for example, 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and the answer is 362,880. This is all on your calculator. I will show you. I go to, I would hit the number 9, and then math, and then over to PRB, which is probability, and hit the factorial, and then hit equals. There you are, 362,880. Now, when we talk about permutations, this is going to be an arrangement or a lineup of objects in which now the order matters. Before, the order didn't really matter with making cones and arranging numbers on a license plate. Order doesn't matter at all. But now, we're going to be dealing with situations where order does matter. The notation for permutation is lowercase n, capital P, lowercase r. And the formula for that is n factorial divided by n minus r factorial. Lucky for you, the calculator will calculate this for you. The shortcut that you can know is that it's really just n factorial. But here we go. In how many ways can you arrange the letters in the word dinosaur? Again, order doesn't matter. All I want to do is take these 1, 2, 3, 4, 5, 6, 7, take these 8 letters and arrange them in such a way that I make a new combination of letters. So that is 8P8, which is the same thing as 8 factorial, which is the same thing as, let's go over here. So on the calculator, I can go to math, over to probability, and then down to here, NPR, and I'm going to type in 8, and then over to 8, and enter, and that's 40,320. Okay, more examples here, which I am going to skip while we talk about permutations with repetition now. So if there's a situation where one of your inputs repeats, let's say arranging the letters in the word automobile, I'm going to take the total number of letters in automobile, which is 10 factorial, or 10, and I'm going to divide it by the letters that repeat. So that would be O, so that by 2 factorial, because there are 2 O's. What I'm going to end up with is, well, let's see on the calculator here. I'm going to type in 10, go over to math, probability, factorial. I'm going to divide that by math, probability. Whoopsies, I forgot to type in the 2. Let's see if I can go back and do that. Yep, 2 factorial. And get 1,814,400. 1,814,400. Now, with combinations, similar to permutations, however, one important difference is that this is a group of objects in which order doesn't matter. For example, if Natalie has 16 close friends, how many ways can she choose 5 to be bridesmaids in her wedding? Well, 16, a combination, so I just want groups where order doesn't matter, of 5. And so that's going to be that n factorial divided by r factorial over n minus r factorial. You do not need to memorize these formulas. You just need to understand that you can use the calculator for help here. So I'm going to go to math, over to probability, down to combination, and type in 16, combination 5, enter. There are 4,368 ways that she could organize or get a group of 5 out of her 16 friends. Okay, next question, next page here is this a permutation or combination? I'm going to ask you to read the question, identify if it's a permutation combination, and then do the work. So let's look at example 1. How many ways can 4 candy bars be chosen from a store that sells 30? Does order matter? Very good. Order does not matter. No, order does not matter, and so it's going to be a combination where I've got 30 candy bars to choose from and combining them into groups of 4. That would be 30 factorial divided by 4 factorial times 26 factorial. But the way to do that is just on your calculator with math, probability, combination. Oopsies.
AI.
Sorry. I guess this version comes with ads. So on your calculator, you're typing in math, probability, 34, and you're getting an answer of 27,405. The rest of this page has you go through permutation or combination and getting the answer. Tonight's homework is to do the odds on homework 1. And good luck. We will talk about this in class tomorrow.